Hello, I'm going to take you through the tricks to recall all thermodynamic identities. Let's go. First, draw a rectangle, label it VAT, VAT for the top, UG for the side and side, sharp for the bottom. VAT, UG, sharp. Make sure you recall this. Then now draw arrows facing upward. Then here, minus, minus, plus, 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 minus, minus. Well, now, first of all, we are going to go around the box and then inside the box. And each of them is going to give us a corresponding relation, identity. So let's start with Maxwell's relations. So Maxwell's relation for thermodynamics. So we are going to look for our U, our Helmholtz, our Gibbs free energy, and then our enthalpy. Let me put this ones in red. Red, UG, H in red, E in red. Hope you can see. So let's go. We are going to stand on U, then we look at the angles facing U. This angle and this angle are facing U. So we stand on the angle and we move towards U. We stand on the angle and we move towards U. So for U, which is internal energy, this angle faces U. So we stand on T. It's going to give us dt. dt, jump the red one, dv is positive. Then when we are out to U, the one after U becomes our constant, which is S here, our entropy. So into bracket our constant S. This angle also faces U. So we also start on this and move towards U. So now this equal P, dP, but P starts with minus. So minus partial derivative of P out of, we jump the red one, partial derivative of S. Partial derivative of S into bracket. What is our constant now? We are up to U. So the one after U becomes our constant, which is V. So V here becomes our constant. So we are done for U. Let's go for Helmholtz. We stand on A. What are the angles facing A? This and that. These are the angles facing A. So we stand on this angle and move towards A. We also stand on this angle and move towards A. So here P starts with minus. So P starts with minus. So minus partial derivative of P is minus partial derivative of P out of, we jump the red one, partial derivative of T. Partial derivative of T into bracket equal. We do same for the other side. This angle also faces A. So we do same for the other side. We start with S. So minus partial derivative of S minus partial derivative of S divided by, we jump the red one, partial derivative of V. Partial derivative of V all into bracket. What is our constant now? S, V, we are up to A. So the one after A becomes our constant, which is T. What is our constant here? We do for P, moving A. Partial derivative of P, we jump the red one, partial derivative of T. The one after A, which is V, becomes our constant. So V here becomes our constant. Hope you are following. Let's do same for Gibbs free energy. First of all, we stand on G and we look at the angles facing G, which is this and this. They are facing G. So we stand on this and move towards G, and also stand on this and move towards G. So partial derivative of V is positive. So V starts with positive. So partial derivative of V out of, we are moving towards G. We jump the red one, partial derivative of T. Partial derivative of T. We are up to G. So the one after G becomes our constant into bracket P as our constant equal. We are done for this side. This angle also faces G. So we stand on this and move towards G. So partial derivative of s is negative. S starts with negative. So negative partial derivative of s out of, you done the red one, partial derivative of p. Partial derivative of p. We are out to g, so the one after g becomes our constant, which is t. So into bracket t. Let's do for h. For Helmholtz, we stand on h. What are the angles facing h? This and this. These are the angles facing h. So we stand on t and move towards h. And we also stand on v and move towards h. So standing on t, we have our partial derivative of t, which is positive. Partial derivative of t, which is positive, divided by, we jump the right one, partial derivative of p. The negative sign only comes in at the starting point. So divided by partial derivative of p. All into bracket. What is our constant now? We are up to h. The one after h is our constant, which is s. So equal, we stood on this, now we stand on this. So partial derivative of v, which is plus, put partial derivative of v, partial derivative of s, we are up to a. The one after a becomes our constant. So partial derivative of v out of, we jump the red one, partial derivative of s, or into bracket. What is our constant now? We are up to h. The one after h becomes our constant, which is p. So these are the Maxwell relations for thermodynamic. So now let's look at the partial derivatives of the, let's look at the other functions too for u, g, a, and h. So let me write it here. U equal, so now we are done going outside the box. Now we are coming inside the box. We are done going outside the box. Now we are going, like, we are going inside the box. We are going to take the inside of the box into consideration. So now, if we stand on u, what are the angles facing u? It's still this and this. This start with positive, this start with negative. So these are the angles facing u. So t ds. Are you listening? T ds. So t ds. We are done with this. This angle is also facing u. So minus p, it starts with the minus. Minus p dv. Minus p dv. This is for u. So let's go for g. G equal, we stand on g. What are the angles facing g? This and this. So v dp, which is positive, is, I already told you that is the starting point that will tell whether it's negative or positive. So v dp. So we are done with this. Let's come here. S dt. S is negative, minus s dt. So let's go for h. H equal, we stand on h. What are the angles facing h? This and this. So t ds, then v dp is positive. V stands with positive. So v dp. Let's go for Helmholtz. A equal, we stand on a. The angles facing a are this and this. So s dt, p dv. S starts with negative. So negative s dt, and after that, negative p dv. P starts with negative. So negative p dv. So we are done. The last term you have to add is the chemical potential term, which is mu the n. So you add this to each of the terms here. So plus mu the n, plus mu the n, plus mu the n, plus mu the n. We are done. With practice, you can write this thing in just 1 minute, and you'll be able to analyze a lot of things within that 1 minute. You understand? I mean, you'll be able to save time to do a lot of things. So these are the thermodynamic relations. So with this, I think you'll be okay. So if you like this video, kindly subscribe to my channel for more content like this. I have a lot of contents for you. So see you. Bye. Don't forget to add d to the partial derivative.